In this lesson, we're going to begin working with radical expressions which have variables. And we're going to use just a couple of ideas. One of them has to do with inverse operations. Remember that an inverse operation undoes what an operation does. That leads to the idea of the inverse property of squaring and square roots. Notice that the radicand has to be non-negative, that is greater than or equal to 0. The other property that we'll be using quite often is the product property. I'll begin with this first one. There's a couple of ways that people can do this. I'll start with the one that kind of makes an argument to the two ideas we just talked about. If I think of k to the fifth as k squared times k squared times k, notice this is the product property for exponents because I'm multiplying and bases are the same. I could add the exponents and get 2 plus 2 plus 1, which would be my original k to the fifth. Using then the product property for radicals, I can write this as 3 factors. 2 of the factors will be square root of k squared, and the third one will just be square root of k. Using the idea of inverse operations, each of the square root of k squareds is just a single factor of k. Multiplying the two factors of k, I get the final product, k squared square root of k. Try this one. Begin by writing the radicand a to the sixth as 3 factors of a squared. We can then use the product property to have 3 factors of square root of a squared, and using the idea of inverse operations, we have a times a, since each square root of a squared is just a single factor of a. 4 factors of a multiplied would give us 2a to the fourth. Be careful, some students get 5a, but that's because they're adding. Notice that we're multiplying here, so we have to use the product property for exponents. Here's one with both numbers and variables. Thinking of 63 as 9 times 7, and x to the fifth as x squared times x, we can use the product property for radicals and simplify to get 3x squared square root of 7x. Notice that the square root of 7 and the square root of x should be combined to just the square root of 7x, again using the product property. Here's another. If we think of 12 as 4 times 3, we can then use the product property and simplify and multiply to get 4y to the fourth square root of 3. There's a second common way to simplify problems like this, and it's based on the idea of division. First, we'll get a little vocabulary. If you divide 2 into 7, 3 is the quotient, and after subtracting, 1 is the remainder. Here's how we use this idea. Say we start with square root of 7. Keep in mind that there's an index of 2, even though we often don't write it. When we look at x to the 7th, we'd like to know how many x squareds are factors. One way of finding out how many 2's are in a 7 is using division. So if we divide 2 into 7, our quotient 3 is the exponent on the base outside of the radical symbol, and the remainder 1 is the exponent on the base inside the radical symbol. Again, what's really going on here is that we have 3 factors of x squared in the radicand, and 1 more factor, which gives us our 7th factor. Of course, we usually don't write the exponent of 1 on x, so this would be the way our final answer looks. Now let's practice applying this approach to a few problems. Try this one. Remembering that the index for a square root is a 2,
Well, 2 goes into 5 twice, so the exponent of k outside will be k squared, with a remainder of 1, so the base of k inside will have an exponent of 1, which we usually don't write. Here's another. This time our index of 2 goes into 6 3 times, so our exponent on the base of a outside will be a cubed, and inside the remainder will be 0. Now recall from the exponent rules that if we have a non-zero base with an exponent of 0, that's really 1, and the square root of 1 is 1. And if our product has a factor of 1, we don't really need to include that. So once we add the exponents here, 1 and 3 is 4, we'll have 2a to the 4th. Try this one. I'm sure you know that the square root of 4 is a 2, but let's take the approach we're working with and think of 4 as 2 squared. Then 2, the index, divides the exponent 2 one time, so there'll be one factor of 2 outside, and no factors of 2 inside. And then 2 divides 7 3 times, so we'll have a k cubed outside with a single factor of k inside, since the remainder is 1. How about this one? We already have factors of 5 and h squared, and for values inside the radical symbol, I often like to go through and prime factor them. So using our techniques from before, we can see that we can write 8 as 2 cubed. Then 2 goes into 3 once, so we'll have a factor of 2 outside, with a remainder of 1, so we'll have a factor of 2 inside. And then the factor of h will just stay inside the radical symbol. We can still simplify, since 5 times 2 is 10, to 10h squared, square root of 2h. Try the approach on this one. I hope most of you say to yourself, well, square root of 36 is just 6, so I can bring out a 6, and then I'll have a negative 24 when I multiply the factors. But let's take the approach we've been working with and think of 36 as 2 squared times 3 squared. Then the index 2 will go into 2 once, so there'll be one factor of 2 outside. And again, 2 goes into 2 once, so there'll be one factor of 3 outside. And then a third time 2 goes into 2 once, so there'll be one factor of x outside. Now, it's true that this will leave exponents of 0. But again, all of these will just be factors of 1 under a square root, and the square root of 1 will be 1. So nobody writes this. Instead, they just write the factors that came out, the bases of 2, 3, and x. We don't really need a radical symbol anymore. Instead, we can just multiply the factors and get negative 24x. Here's another. After prime factoring, 50 is 5 squared and a 2. The factor of 2 will stay. For the 5 squared, the index of 2 will go into 2 once, so a factor of 5 will be out. And then 2 will go into 6 3 times, so the y cubed will be out. Again, the factor of 2 that was there originally just is going to stay. And now I can multiply in any order, so 2 and 5 will be 10. And 2 factors of y times 3 more will be 5 factors of y. And here's our last one. 45 prime factors to 3 squared times 5. 2 will go into 2 once, so one factor of 3 will get out. The factor of 5 will just stay here. And then 2 will go into 5 twice with a remainder of 1, so an x squared will get out, and one factor of x will remain. To simplify now, I'll multiply 9 and 3 and get 27, And then bases are the same, and I'm multiplying so I can add the exponents and get the fifth power of x. Well, that will conclude our work where we've been simplifying some variable radicands.